Yeah, we're going to start this talk. Maybe in other talks, you have seen the past. Now you're going to see the future. And I'm going to explain why. Long time ago, with my friend Ivan, we went in Barcelona to a meeting when first company meeting of a company called SkySQL that becomes MariaDB later on. And we have a chat about what should we do for the future of the company. And it was all about, we need proxy. We need a proxy because, you know, this Galera stuff, eventually consistency, Paxos, all those new stuff, they still need a leader. Otherwise, it's not consistent. And become the idea of MaxScale. And I was very against this idea. Because for me, the proxy should be under the optimizer. And should be in the database itself, and not a separate pieces. For some business reason, we decided to make the proxy outside, or the management decided to make the proxy outside because it's more easy to get money with something outside, prove that it's your own code, etc., etc. So now we have like an ecosystem with a lot of proxies. We have HashaProxy, we have Proxy SQL, we have MaxScale, but nothing is like Spider under the optimizer, being able to do joins and things like this. So the idea is to create another proxy called shardproxy, which is not a proxy, it's a database, it's a MariaDB database with a spider, and to make it react like a proxy. And we're going to see why we should do that. What's wrong about sharding frameworks? Like Vitess, maybe you heard about it. They mostly don't do efficient joins. They don't know how to do joins because they are routers. It's the same thing for MaxScale or for Proxy SQL. It takes the query, route it somewhere. If the data is split in pieces, it's very hard to combine the data again. So it means that the proxy should do the join. But if the proxy do the join, it should also monitor the nodes to know the cardinality of the index, to know everything. So the proxy should become an optimizer, and a parser, and a something, and something. So that's the long story of MaxScale that bring feature one by one. It takes very long time. Maybe one day, Proxy SQL or MaxScale will become such tools, but it's long process to make it happen. Most sharding frameworks don't preserve acid properties, consistency, durability, things like this, because they are in front. They don't know how to manage shared data, which Spider can do with two-fast commit. Most of the sharding framework that I know don't do two-fast commit, so if you roll back one node to one shard, then it doesn't roll back the other one, you end up with inconsistency data. It's bad. So also, for example, in Vitess, they tried to recreate SQL parser. So Vitess is an HTTP interface. You passed it like a query, but to HTTP. And then it take this query, parse it, and try to do things with shards. But at the end, the parser is very limited. It's a rewriting of an existing Oracle or MySQL parser with very limited SQL. It's in Go. It will again takes how much as long as it took for the MySQL team or the MariaDB team or the Oracle team to create a parser. It's something tricky, very not easy to do. And they mostly force you to change your code. So that's not good. What's wrong about clustering databases? They don't scale right most of the time. They just, like Galera, we saw group replication this morning. You write to one place, it's replicated to other nodes, then you have a good latency. It comes back, everything is synchronous, but the writes happens everywhere. So it's not really scalable. You have to find the scalability outside of this by making your own sharding, putting the invoice table or microservices, way of developing the application. So they duplicate data before commit. Also, it's not very good for long-running transaction. the good way, old way that you do big batch to modify everything. This is not working with clustering solution because of locking issues and things like this. They told you, don't do that, don't write on all nodes, because it will break and your transaction will be rolled back all the time. Same old story. We used to have it in Oracle RAC. We used to have it now in Paxos systems like the one that we can see now. And so some people, they say, okay, I don't use clustering, I don't use sharding framework, I'm going to scale up. Take the big machine, buy it to IBM, very high priced, half terabytes of memory, blah, blah. What's the problem with that? There are still some problems. If you put 1 million tables in a database like MySQL or MariaDB, even Oracle, the metadata will be big, locked. Oof. Can I take my backup after that? I'm not sure. Still a long way to go before a database system can manage 10 million tables, take a backup under constant DDL work, like alter table, add table, drop table. I never saw. Otherwise, we would not have database engineers to tell the developers, don't do that. It's stupid. You should not do that. When you lose your big system, you lose everything. If you put everything in the same bottle, it's not good. And also, dividing things, sharding things, makes the system information a lot more resilient to failure. Because if you lose this data mart, you don't lose this one. For example, if you are split by country, you lose Germany, you don't lose France, you lose Spain, you don't lose US. And also, last time I went to the clients, 2 terabytes database, 1.5 terabytes only read-only data, the past. So you don't back up the past the same way you back up the very online analytic processing. You back up the past by taking a backup once a month, put that in somewhere, but you don't have to lock the whole things, be consistent. So different usage of the data includes different operation on the data or maintenance of the data, maintenance policy. So the idea is to have now a lot of small clusters. And to manage those small clusters, we prefer, or we see that big companies like Facebook, Google, Chinese now, like Alibaba, the Tencent, they all use like a lot of small little cluster. Google started this stuff for the first time. Many small grabs, or we call it shard group in a sharding environment. And so it was important for us, for CNI 18, to have a tool that manage this complexity. Facebook has its own tool, MHA, made by Yoshinori, which works for Facebook. Booking as it used to have this requirement, they hired Shlomi, creating orchestrator. And you, and the enterprise, the small enterprise, what they have, nothing. Now Shlomi is in GitHub. So all the other small actors, why not doing like the big ones? And so we created replication-manager, which enable to manage this. But replication-manager manage the route to the data, like we saw this morning for example, group replication on MySQL. We need a router in front. So they explain proxy SQL, explain a little bit MySQL router. So there's a route to the database. So I would say in a microservice approach, you would forget about those proxy. You would go directly for a consult DNS. I write to this node, and then the backend IP of the DNS change. No need a proxy for that. Then you have security reason. Then for very advanced proxy stuff, you would use MaxScale or proxy SQL to control more. It's a DBA tool. It's not a sysops tools, a proxy. Especially layer 7 proxy, which goes and use CPU to do a lot of things. And so what we want to present here is Well, so replication manager can work with scripts as well. Maybe you manage your virtual IP yourself, and so it will call the script to change the virtual IP or whatever. But what we want to show here is the shard proxy approach. So Spider, maybe you saw the talk this morning, is table per table partitioning. Each table is a view on one or multiple tables on other backends. And that's damn complex to produce. You have to be the DBA, oh, new table is there in this backend, I have to link it and everything. So we need something to make Spider a proxy. And what does it mean? Let's see. It means, well, first that's the big picture of replication manager, just to show that on an infrastructure, you can provision clusters. So I use OpenSVC, could be Kubernetes or whatever, but you provision cluster as you want. So now the number of shards is not a problem. You say I want 10 shards group, you'll get 10 shards group. We have a notion in sharding of virtual schema. A virtual schema is not only the schema you have in one database, it's a schema that track all the backends. So it's like a metadata that say, okay, this table is here, here, here. It's the same table. So we did that in Replication Manager. We first started to have a generic monitoring schema solution that for each monitor server in Replication Manager, we track the database structure, the sec star from MySQL schema.colons. We do a group by on this, compute CRC32, then we know is exactly that this is the same table here and here in this backend and these other backends. And we track this and we aggregate all the different shards group into a single shard group or a view of a shard group. And what we do, we call an event. This is all in Go. And we call an event because that's very convenient in Go. You push something as an event. And then we say, oh, this new table is here. I discover it. It was created or modified by someone, by a DBA. And when this happens, in the shard proxy plugin, which I have plugins for every type of different proxies, okay, I have to update all the Spider nodes or all the shard proxy nodes to get this new table created or modified at some point. And then I hard-coded some very simple rules. Simple rules is that if I discover table city on this backend, I create table city on the database.ct, world.ct, for example, on Spider node. And if I have two table city, then I do a hash by primary key on my discovering. So I look at the primary key of the table, or the unique key of the table. If there is one, I just hash by primary key. So very simple. And so you add table in the system, you modify table in the system, they are also up to date in the Spider nodes, or the shard proxy nodes. In Replication Manager, as I say, some clients, they have 1 million tables. If you do that, you're dead. Going and select tables in the information schema for 1 million database schema will take ages. So I don't want this feature to be on by default in Replication Manager. I only want some clients to activate it. So there's parameters for that. Also, because I track the tables, it's easy for me to call a script, an external script, and it gives you an entry point for you to do whatever you want with this. So, like, for example, if someone drops a table, maybe the DBA wants to know, oh shit, what's happening on my database? Maybe an injection or something? So, okay, you can use that. Doesn't cost much for me. Failover and switchover, the way they work, so there is better solution, but today I reattach the, so Spider works with something called a server. When you are in MySQL or MariaDB, you can create server, and you give the host the user and the password, and then you attach the partition to those servers or the table to those servers. So the idea here, I'm in my failover or switchover process. There's a some point I need to change the root to who is the leader, and when doing this, I will update my MySQL server table with the good master or the good writer, and then do a flush tables, and then all the tables are like this reattached to the real master. So if there is a failover, one master die, we take a slave root, and it's automatically following. It's not the best. Maybe in the future, in my to-do list, I have to do, like, for example, you have a max scale in front or a VIP, maybe pointing the table to a specific VIP, and then like this, if one spider died, and come back after that, okay, oh, I need to detect that. And so today it's very basic. I mean, I do refresh all the time of this information. If it's wrong, I recreate. But what happens to the writes during that time is like a mystery. Maybe someone already hit the spider nodes and goes to the old master, which would be catastrophic. So maybe it's better then in the future to improve that. So today, if you want to use this feature, use it as with a spider, one single spider as a failover until we improve the solution that it works for multiple spiders differently. Okay. So we have some way to see the virtual schema from the replication manager API. For example, you call the API, well, usually it asks a user and password, but because I hard-coded the same user and password in the client's API, you don't have to provide the password unless you change the configuration file for different user. But it will list you in JSON the tables. What we compute is the number, well, this is well known because this is from the information schema. You have the data length, the index length. So that we compute by replication manager. It's the hash of the column names and data type. So if someone do an alter table or change the type, this CRC will change, and I can then monitor that and give a trigger that it's changed. And also the list of clusters that have this table. So here it would be, it's not a good example, but this table is not sharded, it's only on shard 2. It's not on shard 1 and shard 2. Okay for that? Then you can do something like replication manager API, reshard the table word.ct in that is today in shard 2. And then we will auto-reshard the table that it goes to all the nodes, all the shard group of the cluster. So it's automatic resharding. I will give you a demonstration of that. Let's see it. Okay. I'm gonna load the Word database into. So this demonstration is on my local machine. You want more? Yeah. I know. It's always like this in demo. Okay, is better? Okay, so before doing this, I'm going to show you that I run multiple MySQLD on the same on my development machine. Okay, and the way I do that is by using something called replication manager test. I will run it. I give a configuration file, and this is replication manager server daemon. And so now replication manager daemon start to monitor both clusters and everything. And I use replication manager and underscore test. So we have 3 flavors of replication manager. One flavor is test. It means that when you provision something, it's provisioned locally. A MySQLD or whatever, or a shardproxy, it will go and search the binary of MySQLD and run an instance of it when you do provision of a cluster. So that's why it's called test. Then we have the OSC release, replication manager OSC, which is open source, which means all the features, basically, but without the provisioning. And then we have Replication Manager Pro for provisioning that talks to OpenSVC to deploy cluster on real cloud or on real physical infrastructure. We had a talk yesterday about this. So now I'm using the test release so everything is managed locally. And I can start and stop things. So here I have two clusters. Let's pick one, for example. OK. So my cluster, there's a master, a slave. It's up. And if I go to proxy, you see that there is a MariaDB 10.2.9, which is my spider proxy. So each of the two clusters that is present in the configuration file reports to this spider node, or MariaDB node with spider, let's say. That's what I call shard proxy, but it's my own terms. OK, so now I'm going to show you the logs. Well, something that you saw this morning with MySQL presentation as well is that you have like a list of alerts and errors. So on the cluster, there's no errors, but there is alerts. For example, it can tell me that there's a physical backup running, or no GTID strict mode, a lot of things that you may improve your configuration. So those are basic configuration. You can go there and read. It's good to have. Let's now create. So let's look at the log here. And I'm going to increase the size again, that you see better. OK, this is the logs. So logs tell me that there's an internal scheduler in replication-manager to take backups, to fetch logs and everything. So he loads those. What is the frequency of fetching the logs? What is the frequency of taking physical backup, logical backup, blah, blah. New server monitor. So he found 2 servers to monitor for this cluster. Etc., etc. And you see already he has pushed down some tables to replication manager, to shard proxy over there. There is a job and a bench table that have been pushed down to Spider. Now I'm going to load the city schema. So where is it? The word schema, sorry. OK. Oops. OK. That's a request to Giuseppe that maintains the word. Thank you. Create schema word. Where is it here? Oh, no. So I will put it to, so my master is port 3333. Create database word. OK, now I'm loading the word into this master. And if I go in my replication manager, at some point, well, I can have it also on the command line. It will discover those tables and push them to spiders. So when you go and log to the spider nodes, which is on port 336, we will see the old tables of the word schema. We're gonna. It's not super fast, huh? OK, now it's done. Now I'm going to log into Spider, or shard proxy, into Word, show tables, nothing. Shit. Oh, yes, the time it's discover. So now the table, oh, you have seen that in direct. So, so now you have a tables that appears, and if you look at show create table CT, you can see a spider table, which is the backend is MySQL, the table is named CT, and it's attached to the server, which is a kind of hash, internal hash of me to tell the cluster name plus the schema where it attached the cluster name and the schema in the hash, so that multiple clusters have different hash and different server name. OK, when it's done, so you can also select from the CT table. Select from city. Let's do that. Limit 10. What did I do here? Oh, yeah. Yes, thank you. Sorry, I'm developer, not DBA. City ID, maybe I have the country code. I can join the city just to show you that I can join the city inner join country using country code. If it doesn't work, complain to using country code. It doesn't work. Huh? No, it's not the select star. It's because no, but the country code is not in the two tables, which is badly designed. So it's because let's call this city. So CO and CI. Okay. And so co.code equals ci.countrycode. No. Where? No. On. Yes, thank you. Country. On. Okay. No. Yeah, thank you. Whew. Okay, thanks, man. Okay, so using Spider, we were able to join the city table and the country table, and even here, there, Spider detect that it's the same backend, because we already push to shard 1, so it do direct joins. Maybe it's super fast, yes, because of that. So it pushed down the whole query, basically. Now, let's use our magical Oh, yeah, sure. Is it better? Yeah. So I want to show you first, for example, I go to shard 2, and I have here the list of the tables. Then I go and do my reshard city table. So from that cluster shard 2, schema word, table city, action reshard table. It takes a while. So it takes a while because the inserts now is a single inserts row, but that's because my Spider is on macOS. I compiled myself, sorry. And but this is fixed in other release, okay? Let's now have a look at, well, it's not finished. We can look at the log maybe. Oops. Not yet finished. Okay, now it's finished. And if we go here to the Spider node, we can do show create table, city. Oh. From a single attachment, federation, now we have a partition table by hash of primary key ID, city ID, which points to the two backends, shard 1 and shard 2 masters. Yeah. If you do explain partition, yeah, explain extended or something like this, because then it's no more than regular partitioning, except that Spider is behind the partition handlers and retranslate handlers to SQL. Yeah. No, to do that, you have to enable the Spider general logs. So you activate the general log, and then you activate Spider logs, and then you can see even which query is sent to the backends specifically. But otherwise, you know that it goes in this partition, and because this partition is attached. So let's retake our it's always as fast as usual. Now connect to one master. So 333. Now if I select star from city, you can see that there's only 2,000 records out of 4,000. It gets all the odd number. I go to the other master, 331, and then you have all the. Oh no, it's not the. That's the odd. Yeah, it's the opposite. Hmm? Is it odd or even? That's even. Okay, sorry. My English is not good. I know. Even in English, I mix up left and right, so odd and even, same. So the advantage of this technique, you can still insert into the table at any time. The city table, you can do updates. It's reshard transparently the whole stuff. Okay? So now, what's the next steps about this? This is quick development, I would say. The next step is to define in this call, because nowadays it's all or nothing. So if I have like 3 shard groups, I will hash on the 3 shard groups. But I would like here to say a list of shards group that the table should be split. If, for example, there's only one shard group, it would mean, and it's different from this one. For example, here, I only put shard 1. The table will be not partitioned, but moved to the other shard. So imagine you're a big provider, and you hold many clients, and you see that one client has a big table that requires you to put it outside, because it's so big that it's not easy to manage. Then you can just move the table in a new server or in a new set of server. And then if it's even too ugly, you can use the sharding to split it around all your stuff, all your clusters. So here, the table list of clusters that I use is all. But now I need to go a little bit further and try to make that more precisely. Also, what I want to do is this is a default way of working. I also want to have additional dictionary or sharding dictionary into the spider node as a table, so that we override the default. So, for example, if you don't want shard by city ID but by country, you can specify that there, and then replication-manager will read that and do the job for you. But today it's only like look up for primary key and do this feature. Yes. Well, I can fail over or switch over. Yeah, okay, the master moved. Well, it's not very, because I have no rights, but so it's not very attractive as a demonstration, but just to tell you that here, the spider table has been refreshed to point to the new master. If I do select star, I'm not in the spider. Spider is here. If I select star from MySQL servers, is it? Yeah. So you see that, which cluster is that? That's shard 1. On shard 1, the master is now 332, which is correct. My master is on port 332. So the spider has, I switch over the master, and then the spider table will relinked to the good master. I think that's almost done for my presentation. Let's see if there is additional slides. Yes, that's the way to define the configuration in a replication manager. So basically, you have like you define 2 clusters in replication manager, and then you say you can add a defo section, which is mandatory. You need to have this, default section, and then you say, okay, shardproxy true, and shardproxy server, you give the list of server and the user password. End of the story, and it's done. But you can, of course, add a lot of shards and a lot of shardproxy servers. Thank you.
Okay, so would like to welcome everybody. I'm Lucas. Today's talking is about cloud, especially engineering clouds and tools to use to make the use of the cloud solutions better and easier for companies, no matter which segment of business. Pretty much everybody's using cloud today, and that's our main topic. I started my career very early, at 16, and after 15 years, working with different kinds of technologies and clients and environments, working inside data centers, it was some kind of a passion, starting with networking. Then things quite evolved a while, and I really fell into this evolution of virtualizing everything, especially components like compute, storage, and networking. So I was able to work with a bunch of different clients and projects, very exciting ones. In these past 5 years, working only with cloud. And this was in between Brazil, Los Angeles, and now Barcelona for a year. And yeah, some good projects. So today I want to cover some topics like why cloud, why it's growing so fast, why the companies should be in the cloud already, the difference between being a cloud architect and a cloud engineer, and what is exactly cloud engineer and what is the role, and dive into what is cloud native and why the companies should be adopting cloud native technologies. So cloud services, right? The definition of Wikipedia, it's very accurate. And basically, in the history of computers, we faced this paradigm of a clustering pool of resources many times back in the 80s with the mainframes to get more power and so on. But now we are seeing the same movement, but in a macro scale, basically worldwide. And we are seeing like governments using cloud. We got the first 4K transmission from the International Space Station, thanks to the cloud infrastructure. And most of the modern life depends on cloud. So you can imagine if services like Google goes down for a minute, people think that internet crashed or something like that. And the majority of the businesses around the globe are using cloud technology, both to support the local logic of the business and provide to the end customers products as well. So why it's growing so fast, you might think, is in the last 5 to 10 years, We saw a lot of traditional data centers fading out and more companies adopting cloud. This is because cloud, you can get a lot of advantages, and this enablement via having a common base, or you can call it an API that you can, basically the cloud provides you an API. You can pretty much build automations on top of it and consume better and have some resources, schedule resources much more faster in a way that you couldn't before. You can provision a huge amount of workloads in a very small time frame, which automation platforms and infrastructure as code platforms like Terraform, CloudFormation, Heat, and many others. And this creates velocity for today companies and businesses, right? So this also brings up a clean approach to the traditional data center model, where if you want to have some kind of replication, you would have to spend a lot to have a recovery system fast enough to to fail over or to be full HA. And with cloud and provisioning tools and infrastructure as code, you can reach like the sweet spot of having a well-designed and well-drafted recovery strategy that would not cost much, but it will be effective according to the business needs. So the question is why companies should go to the cloud, or why companies are not yet on the cloud. You can see here the evolution in the past. I can say here in this graph, in the last 10 years, when we 10 to 15 years, when we start to use virtualization as the de facto standard for data centers and applications. So you see that an evolution happened, and the end goal of this is what we call cloud today. Back in the days, there was not a term to that, and you can see that you start to increase a lot of cut a lot of complexity by managing the infrastructure. Then you cut the complexity of managing the VMs or virtual systems, and you focus on on the service you want to provide. And with that, you can get more focused on the business logic and the revenue itself. So it's very important for a company to have a cloud strategy in place. Scaling is practically unlimited. You can have your workload auto-scaling from one machine to 1,000 machines in a matter of minutes, depending on your accesses and so on. And you don't have to pay for resources that you're not using. For instance, if you want to build a prototype, you can simply shut down and pay only when you're working on it. So there is the question, where should I focus my cloud solution? Public clouds versus private clouds. We can see that Amazon, as today, is the leader of the cloud segment, with more than 90 services and more than 3,149 features since the foundation in 2006. And for private cloud, especially OpenStack, which is the leader for today's technology on private cloud. You have basically you don't have the same number of features, but you can adapt for your business, because most of most of the companies that uses private cloud, they use for a specific reason. That would be privacy concerns or legal concerns about storing data, not putting data in a shared environment, and so on. And with that, we move to what is the difference between a cloud architect and a cloud engineer. So an architect, in analogy, would build this draft or this blueprint for you, showing basically what you're asked for, like how it should look like, and nothing else. Like basically very high level, detailed on how it should work, right? So the role of the cloud engineer is to go deeper and study like what's going to be the workload and so on, so you don't get like results like your house collapsing or something like that because the architect did the math and he did it right. So we need a little bit of engineering on that. So cloud engineering is a field of engineering that focuses on cloud services such as software service, platform as a service, and infrastructure as a service. And Gartner defines cloud engineering as the process of designing these systems to leverage the power and economics of cloud resources to solve business problems. Right, so normally architects' scope is to make this blueprint of how the application should work, or how the your workload should behave, and the outcome of this behavior that will translate to your business logic or to your application. And engineers take these blueprints, assess many types of details, and select the tools and components to use, and make sure that everything that the architect design will be in place. In the analogy, architects would design like bridges, warehouses, buildings, but it's up to engineers to assess if the plan have the necessary foundation, robustness, and math in place, so it supports stress when it's being used, right? So cloud engineers, they pretty much look like this. They have a background knowledge in networking, architectures, DevOps, data center operations, especially for private clouds, and hybrid clouds as well. And have knowledge of major cloud platforms and the tooling set that each cloud platform can offer for you. Also, getting deeper into the knowledge field of an engineer, you have to understand the conceptual, logical, and physical architecture, master many technologies, frameworks, and platforms. You have to implement the solution, quality for the services like high availability, disaster recovery, scaling, so on, and security as well, and develop applications for flexible deployment. We are talking about multi-cloud, so one cloud application should be able to run in multiple clouds. This is up to architecture layer, but as engineers, we could put a thought inside and offer like ways to for the architects to abstract this kind of vendor locking and should and choose wisely like the platforms to run in, and use open source projects. It's something very important, and apply agile and lean principles in design and construction. So the benefits for cloud engineering for companies is basically you're gonna promote cloud native tools and mindset inside the company, removing complexity from many areas. That means the company should stop thinking about deploying applications in traditional ways, like and start to think a little bit more in the broad spectrum of what the current technology offers, like containerization and automation as such. And it brings also leverage for patterns of design for workloads using the cloud native tools. And the company will have a professional that understands the end-to-end needs for any workloads on basically any cloud and leveraging on cutting-edge technologies. So this basically summarize what it is the cloud engineer role inside the company. And I would like to talk a little bit about the cloud native movement. That is applications designed especially to be used on cloud and bring the power of the cloud much more, to the great market. So cloud native is approach to design, build, and run applications. CI/CD is very important. Container engine and orchestrators to manage the deployments. Delivery is done via these orchestration platforms. No matter which orchestration you're using, you could be using VMware orchestration. You can be using Docker Swarm, Kubernetes, any kind of orchestration platform. And this all sums up to the terms DevOps, CI/CD, and cloud infrastructure. So this brings us improved speed, scalability, and better cost management. So you don't have to, comparing to a traditional model where you don't have a cloud. Instead of having to buy all the equipment, the hardware upfront, you would just simply use cloud and get your costs like better managed. When you don't need the resources, you can simply shut down. So this is basically the ecosystem of cloud native. So the main components you should have in mind when applying the cloud native methodologies. So you may asking why my application is running fine, why I need that. So creation of cloud native applications involves like modular based applications and multiple microservices that reduce the effort, and you can deliver in small chunks your application instead of having giant systems with everything inside. You can have better overview of what's happening inside the cluster or inside the platform. You can monitor microservices, see if the application go down. Your visibility is way bigger. Deployability is how quickly you can put an application on production. You can basically reduce the footprint of your deploy by having very tiny pieces that forms a ecosystem instead of having a big monolith that you, when you have to deploy, you would have to deploy all at once and do some kind of cutover or blue-green, etc. Testability, when you're using CD, you want to make sure that the software can be delivered as quick as possible by having a lot of testing in place, especially automated testing. That's very important nowadays. Disposability, if you, for some reason, you want to modify your product, you want to make sure that that module will not cause any pain, like comparing to monolithic systems that you would have to recode or change other parts of the system to have this achieved. And replaceability, if you want to replace products in your ecosystem and deploy in different environments and so on. So a brief comparison between cloud native and traditional work ways. So in cloud native, you have OS abstraction. You can predict how much time to deploy an application because you have the automated test, so easy to predict how much time you're going to need to promote this to production, while in traditional, you would not knowing that. So you have the right size capacity. You can scale up or down based on the demand of the system. Automated scaling to have all of this in an automated fashion without having to provision more servers in your data center just to handle a spike in eventual, Black Friday or something that would demand a lot of load in your server. So you have all of this automated. And you have rapid recovery. That means that if one microservice fails, you can easily recover from. It's easy to recover from one single module than an entire system that is running in a monolithic way. So in the traditional way, you're very OS dependent. The application is very tied up with libraries. It's hard to update one single component and so on. You have unpredictable deployment time because you always need to check with someone, like if you, when you did some change, if this change is not affecting other parts of the systems and so on. You have oversized capacity because you have to estimate for the worst, so for the bigger impact in your infrastructure by demand from customers and clients and the end users. You have manual scaling. That means that you need to configure new OSs or add new processes based on the configurations, and you need to apply these configurations manually. And you have slow recovery. That means that if a component fails in your system, you need to do a failover, and depending on the fail, it can take hours or even days, depending on the type of the failover process that you have in place. So this pictures a little bit what is cloud native versus the legacy way to deploy software. Like, you can see that was not an easy way to do that. I work in several projects that we had legacy software, and it's very much like that. It looks very much like that. And once we migrate to cloud native, it's simpler as releasing a bird or a small module. So about the cloud native tools, this is CNCF, is Cloud Native Computing Foundation. They are like the hub for many open source and also not open source applications to make making the cloud life or working with cloud easier. All of these tools, they are providing like capabilities for cloud deployments, and they are basically the core of many applications we are using today, and we don't even know. The most famous one we can see on the picture is Kubernetes. It's the mainstream right now, and it's fully incubated and is the first promoted application, mature application of the CNCF conference foundation. Sorry. You can find more information on the Cloud Native Computing Foundation page. They have this landscape where you can browse through different applications and see what is the value of each one. Going back here, you can see that they have many kinds of segments about containers, network, services, so on. Oops. Sorry. This is the link if anyone want to take notes. And yeah, this was my points of view about cloud native. Thank you very much.